Okay, so we're going to be introducing factorial designs. Moving on from one-way ANOVA, we're going to be looking at factorial ANOVA. These are the learning objectives for this section, and this is just to introduce some concepts. We're not going to be doing any analyses during this lecture. We'll get to that later. But just talking about the concepts of contrasting factorial ANOVA with one-way ANOVA, main effects, and interactions. These are some concepts that can be a little bit sticky, so I just want to start with introducing them here. And I want you to not only be able to define those terms, but also recognize what this looks like visually if you're seeing a significant main effect and a significant interaction. So this is kind of what it boils down to. Factorial designs have more independent variables than just one. Okay, so a one-way ANOVA, usually you have like three groups or multiple groups, and you just have one independent variable in that case, and that is which group you belong to. Okay, so maybe you're looking at depression severity scores in a placebo group, a treatment 1 group, and a treatment 2 group. Okay, so your independent variable is which group you belong to, whether you belong to the control, the treatment 1, or the treatment 2 group. The dependent variable is the data, as you recall, so the dependent variable would be the depression severity scores. Okay, now we don't have to be limited to just one independent variable. We can have multiple, and that's what we'll get at with factorial designs. Okay, so here's an example from the Howell textbook. So this is representing a study done by Eysenck on the effects of age on memory performance. Okay, so 10 groups of subjects were recruited, either younger participants or older participants, and each group performed a memory task, either doing a counting task, a rhyming task, an adjective. You don't need to know the details of what these tasks actually entailed, but just that they were 5 different conditions, each probing a different facet of memory, and then they were tested on like how many items they could recall. Okay, so there were 10 subjects recruited, and each of these cells in this table, this is kind of depicted in this table. Okay, so you had 10 younger subjects perform the counting task, then you had 10 other subjects, a whole new group, perform the rhyming task, younger. You had 10 older subjects also perform the counting task, 10 older subjects perform the rhyming task, etc. So ultimately, you would fill this in with means. A mean of n equals 10 for each of these cells. Okay, so this mean number of items recalled is your dependent variable. So remember the dependent variable is the data. So ultimately, you'd have a bunch of x bars in here, and the independent variables, there are 2 of them. Okay, so one independent variable is whether you're older or younger. So the independent variable of age, older versus younger. So there are 2 levels to that independent variable. You're either older or younger. Okay. Now you could, in theory, you could examine this with only that independent variable, right? So you got 50 subjects here, you got 50 subjects here, 50 younger, 50 older, and you could just ask the question, do older participants recall a significantly different number of items than younger? You could just look at that. What's the effect of age? Okay. The other independent variable is the condition in which the memory task was performed. Okay. And there are 5 levels to this independent variable. Okay. The independent variable of condition: counting, rhyming, adjective, imagery, and intentional. Okay. Now, you could, if you didn't care about age, you could also examine this independent variable just in isolation and do a one-way ANOVA to examine, are there differences in memory performance? Is there an effect of condition is one of these means, and you kind of just pool together your older and younger participants, take an average of 20 people here, and you just compare these means with a one-way ANOVA. That's perfectly valid. However, doing those analyses might not be all that interesting. There may be previous research that's already established that older participants are going to perform different than younger, and each of these conditions are going to lead to differences in memory performance. Okay. A more interesting question is, do the differences in memory performance depend on, are there going to be different differences? I know that sounds wordy, but are there going to be different differences depending on whether you're older or younger? Okay. So does the effect of condition on memory depend on age? Okay. And what that is actually called is an interaction. Is there an interaction between age and condition on memory performance? Do those two independent variables interact? So here's just a few illustrations, some examples that I thought of, or that are similar to ones that I've seen online. Some examples of questions you could answer easily with a one-way ANOVA versus ones that you could answer with a factorial ANOVA. Okay, so here's an example of a one-way type of question. Is there an effective offense severity on jail time? Okay, if you commit a mild versus moderate versus severe offense, are you going to have different average jail times? Are there going to be different average jail times associated with each of those? Okay, and we hope that that's true, right? We hope that jail time is going to it's going to be different jail times in each of these three groups. Okay, but that might not be a particularly interesting question. If we add another independent variable, then this may become a much more relevant or novel question that you could ask. Okay, how does the effective offense severity on jail time differ based on whether the defendant is white or non-white? Okay, so maybe jail time increases depending on the severity of the offense, but maybe it increases to a different extent whether you're white or non-white. Okay, that would be considered an interaction. Okay, an interaction between race and offense severity on jail time. Okay, here's another example: is there an effective sleep deprivation on memory? Okay, whether you have mild sleep deprivation, moderate, or severe. And you could examine. You could have three groups. One mildly sleep deprived, moderately, and severely sleep deprived. Have them do a memory task, and you could use a one-way ANOVA to examine differences between those means. Okay. If you a question you could better answer with a factorial ANOVA would be, okay, so maybe there is an effective sleep deprivation. Is that going to be different whether a person consumes ginseng versus placebo, okay, or some other drug or substance? Okay, so maybe it does affect your memory, but maybe if somebody has ginseng or some other kind of supplement or drug, maybe the effect is much less. You can handle a lot more sleep deprivation than if you have a placebo. Okay, and then just this other one, just to illustrate that you can have more than just two levels to that other independent variable. So one independent variable would be the effect, a group size, a study group size, individual versus small group versus large group. And you could examine with a one-way ANOVA, does that have an effect on exam performance? Are you going to see differences in average scores between these three groups? And then a factorial kind of design would be, are the differences between these dependent on whether studying is done in the morning, the afternoon, or the evening? Okay, so another independent variable, time of day, and do differences in performance across those three study group sizes. Are they different depending on whether studying was done in the morning, afternoon, or evening? Okay. And going back to the icing study, this is just what the data would look like. So you've got, here's the 5 conditions, and then here is old and young. And you can see there's some means calculated, lots of means calculated. here you've got for old, the mean, and for the counting task for old participants, mean for the counting task for young participants. And then this down here is the mean across both ages. Okay, so the mean of all 20 here. And that's what's shown all down here too. So that's when you're averaging across age. Okay, so you're only looking at the effective condition. Similarly, you can also average across condition and just look at the effect of age. Okay, so if you average across all of these, then you get this mean here. This is the mean for old participants, and this is the mean for young participants. Okay, and then if you want, you can get a well, you need this for calculations. What's called a grand mean. So this is just the average number of items recalled across everybody. Okay, that's just the average performance, regardless of condition and regardless of age. So after you can also depict this graphically after you run all these calculations, and these different shapes indicate the different conditions, and then you've got age 1, age 2. Okay, and here on the y-axis are the number of items recalled. Okay, now if you just kind of look at this and try to get a feel for some patterns that exist, first of all, does it look like on average you're better able to remember things if you're in group 2 or group 1? And you can kind of get a feel for that by averaging across all of these, and maybe the middle is right about here, and then averaging across all these, and maybe the middle is right about here. And you can see that you seem to be better off in group 2, which would be the younger participants. Okay. Similarly, you can also ask if you were to average across age for each of these tasks, does it seem like there's differences between the different conditions? Okay, so if you take this one and this one, you probably put the middle right about here, and then right about here, and then averaging across here, the middle's right about here, averaging across the x's here. And so there's definitely some differences in recall based on the condition. If you're ignoring age and you're just averaging across age, then these points land at different points on the y-axis, and so there is an effect of condition on recall as well. Okay, so what we've just looked at are main effects. Okay, so the differences between the levels of one factor that exist when ignoring or averaging across the levels of the other factor. Okay, so you kind of just average across, either this way or across this way, and look to see are there differences. Okay, now the interaction, that's where differences between the levels of one factor, in this case, condition 1, 2, 3, 4, or 5, and old versus young, does that depend on the levels of the other factor? Now what we're really looking for visually is that these lines, at least how we've depicted it here, we've got some lines going across. If they're all parallel, even if they slope up or down, they don't have to be straight across, but if they're all parallel, then there is no interaction. Okay, now you can see that there's some non-parallel nature to these lines. Here you've got this intentional image that slopes a lot higher than this one, the imagery condition. Okay, so the differences between recall in young versus old depend on whether you're in this condition versus this condition. Okay, so that would be an interaction. Here are some other depictions of when you've got an interaction going on versus not. Now, the lines don't even have to be straight. You could have multiple levels more levels than just two. But these top three are examples of no interaction. Okay, so the difference between A1, A2, and A3, even though there's differences here that the lines are parallel, they follow the same pattern of up and down, and the ones that show interactions, you can see that these lines here are not parallel. They're each kind of doing different things. So these reveal interactions, whereas these ones don't. Okay, I'm out of time, so I'm gonna go ahead and pause. But